P-value approach. With the p-value approach to hypothesis testing, we first evaluate how likely observation of the value of them for the test statistic would be if the null hypothesis is true. The criterion for deciding whether to reject the null hypothesis involves a comparison of that likelihood with the specified significance level of the hypothesis test. The p-value of a hypothesis test is the property of getting sample data at least as inconsistent with the null hypothesis as the sample data actually obtained. We use the delta p to denote the p-value. Small p-values provide evidence against the null hypothesis, but larger p-values do not. Decision criterion for a hypothesis test using the p-value. If the p-value is less than or equal to the specific significance level, reject the null hypothesis, otherwise do not reject the null hypothesis. To obtain the p-value of a hypothesis test, we assume that the null hypothesis is true and compute the property of observing a value of the test statistic as extreme as or more extreme than that observed. For two-tailed tests, the p-value is the property of observing a value of the test statistic z, which is the area under the standard normal curve that lies outside the interval from negative z0 to z0. For left-tailed tests, the p-value is the property of observing the value of the test statistic z, which is the area under the standard normal curve that lies to the left of z0. For right-tailed tests, the p-value is the property of observing a value of the test statistic z, which is the area under the standard normal curve that lies to the right of z0. To perform a hypothesis test for a population mean, there are some assumptions that is simple random sample, normal population, or large sample, and the standard deviation is known. These are the steps when using p-value approach to hypothesis testing. Let us see the example when using p-value approach to hypothesis testing. This is the solution for example 1.